First one is backbone area, and second one is regular area. All area, all zero area is called backbone area. Area zero is called backbone area. Area zero is called backbone area. Getting my point? Area 0. Till now we had configured area 0 only. So all area 0 is now known as backbone area, and all area except area 0 like area 1, area 2, area 3, area 100, area 500, any other area except area 0 is known as regular area. All area except area 0 is called regular area. So if I'm talking about area 1, so area 1 is regular area or backbone area. So area 1 is regular area.
Regular.
Area 0 is backbone area. Getting my point? So
Yeah.
guys,
So
yes, yes,
between area one and area 100, is there any difference? Like if I use instead of
yes,
area one, I want to use area 100.
yes, there is
What's the
some
difference?
difference.
Okay.
Okay, we will discuss. Wait.
Okay.
Now see types of router. So backbone router are those router whose all interface belongs to area 0.
Yeah.
Router whose all interfaces are in area 0 is known as backbone router. Done? Is it clear? Like if I have a router here and this router have some interface, let's say this is R1 and this is F0/0 and this is 0/1 interface. If you have configured OSPF area 0 here also area 0 here and here also area 0. So the router 1 is now my backbone router because you can see all interface of router 1 is in area 0. Yes or no? Getting my point, guys? Here on router
Yes.
number 1 I have put all interface of router 1 in area 0. So router 1 will become backbone router. Okay, after that internal router, so router whose all interface belongs to regular area. Router whose all interfaces are in regular area. Regular area can be area 1, 2, 3, 4, 5, 6, 7, 8, any other area except area 0. So now again I have one router and this time this router have again two interface. R1, this is 0/0, this is 0/1, and this is in area 1. This interface is in area 1, or let's say this interface is in area 1 or any other area, let's say area 2. So all interface of this router belongs to which area? Regular area. So this type of router is known as internal router in OSPF. Getting my point? This is backbone router. Bound router, and this is internal router, internal router. Done. Now what is ABR? So router whose at least one interface belongs to area 0, 1, at least one, at least one interface in area 0 and at least one interface in area and and at least one interface in regular area. Getting my point? What I am saying, router whose at least one interface belongs to area 0 and at least one interface belongs to any regular area, that type of router is known as that type of router is known as that type of router is known as ABR router. Okay, at least one interface is in area 0 and at least one interface is in area 1, 2, 3, 4, 5, any other area, any regular area. That type of router is known as ABR router. Now ESBR. So router whose at least one interface belongs to OSPF domain. One interface or at least one interface, at least one interface in OSPF domain and at least one interface in other routing domain. Routing domain. Getting my point? What I'm saying? At least one interface belongs to OSPF domain and one interface belongs to any other domain. If I will give you the example of ABR router first. So see, let's say here I have one router R1, R2 and R3. R1, R2 and R3. Guys, let's say here I am I have configured OSPF area 0. This is OSPF area 0 domain and this is OSPF area 1 domain. Area 0 and area 1. Area 1. So see, router 1, all interface belongs to area 0. So router 1 is my backbone router. Router 3, all interface belongs to area 1. So router 3 is internal router. But if I will talk about router 2, see, router 2 have one interface in area 0 and one interface in area 1. So router 2 will become what? ABR router. Getting my point? Getting my point, guys?
Yes.
Yes.
Router 2 is here ABR router and ESBR. Let me give you one example of ESBR also. Let's say router 1, router 2, router 3 and router 4. I have 4 router, all are connected like this. R1, R2, R3 and R4. Fine. See, let's say this is my OSPF domain. This is my OSPF domain. Here I am using which routing protocol? OSPF. And here I am using, let's say, EIGRP routing protocol. This is different department. So in this department, the engineer have configured EIGRP. EIGRP. So now see, router 3 have one interface in OSPF domain and one interface is in EIGRP domain. Yes or no? So router 3 will become which type of router? ESBR router. Why? Because router 3 have one interface in OSPF domain and one interface in EIGRP domain. So always keep in mind, router whose all interface belongs to area 0 is backbone router. Router whose all interface belongs to regular area is known as internal router. Router whose at least one interface belongs to area 0 and at least one interface belongs to any other area, that type of router is ABR router. And a router whose at least one interface belongs to OSPF domain and one interface belongs to any other routing domain is known as ESBR router. In EIGRP domain, we can run other routing protocol also, like RIP also. Then also R3 will become ESBR router. Is it clear, guys?
Yes, that's clear.
Okay.
Yes.
Now, see, I have some router R1, R2, R3. Understand how OSPF exchange routing information. When I will configure OSPF on router number 1, R1, R2 and R3. R3. All router ID of router 1 is, let's say, 1.1.1. Oh. Router ID of router 2 is 2.2.2. Router ID of router 3 is 3.3.3. You already know what is router ID. Okay. Now, when I will configure OSPF, routers are going to send LSA1. It is routers notes here routing table. Routers here what LSAs. In loading state, as you know, LSR, LSU and LSAC. Yes or no? So there are some types of LSA. First, discuss about the LSA1. LSA1. LSA1 is known as router LSA. Router LSA. All routers in OSPF domain generate LSA1, and in the LSA1, router is going to keep the information of link. Router is going to keep the information of link. Let's say this is 0/0. This is 0/0. This is 0/0. 0/1 and this is 0/0. Okay, between router 1 and router 2 I am using network. I am using, let's say, 12 network, 12.1.1.0. Between router 1 and router 2 network which I am running is 12.1.1.0/24. Here I am using network 23.1.1.0/24. Done. Okay, now let's say router 1 have one LAN network. Let me do one thing. I am going to put router ID on the top. Okay, this is router ID of router 1, this is router ID of router 2, and this is router ID of router 3. And let's say all router have one LAN network. Switch, switch and switch. Here I am, let's say this is f 0/1. Let's say this is f 0/2, and this is 0/1. Here I am running network 192.168.10.0/24. Here I am using network 192.168.20.0/24. Here I am using network 192.168.30.0/24. Okay, done. So routers exchange LSA1 to share routing information. See, router 2 need this network 192.168.10.0 as well as 30.0. Router 1 need 20.0 and 30.0. Router 2 need 20.0 and 10.0. Yes or no? Yes or no?
Yes.
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 So all routers in OSPF domain generate LSA1. If I will talk about the LSA1 of router 1, let's say this is LSA1 of router 1. LSA1 means router LSA. You can say router LSA. Inside the router LSA, router 1 is going to keep all the link. That I have one link, link number 1, and on this link the network which is running is 12.1.1.0/24. After that I have one more link, link 2, and on this link network is running 192.168.10.0/24. Okay, this is LSA1 of router 1. In the same way router 2 will have also their LSA1. LSA1, that is router LSA of router 2. Router 2 will also keep all the link information inside their LSA1. I have one link, link 1. On the link 1, which network is running 192.168. Let's say 10.0/24. One more link is there on that link, which network is running 12.1.1.0/24. One more link is there on that link, 23.1.1.0/24 network is running. Okay, okay guys, this network is running on fast ethernet 0/0. This network is running on, sorry, this network is running on fast ethernet 0/2. This network is running on 0/0. This network is running on 0/1. In the same way router 3 will also have LSA1, their LSA1. In their LSA1 they will keep these two link information, 23.1.1.0/24 and 192.168.30.0/24. and OSPF share LSA1. Router 1 is going to share their LSA1 to router 2. Router 2 will share this LSA1 of router 1 to router 3. In the same way router 3 will share their LSA1 to router 2, and router 2 will share that LSA to router 1, and router 2 will share their LSA1 also to router 2 also and to router 3 also. So if I will talk that how many number of LSA1 will be there inside the router 1 database. So tell me guys, how many number of LSA1 will be there? 3 number of LSA1 will be there in the database of router 1. LSA1 of router 1, LSA1 of router 2, LSA1 of router 3. Yes or no?
Yes.
Let's say in OSPF domain we have 100 number of router. That means inside the database of all router there will be 100 number of LSA1. 1 minute. But you know, we have one problem. Problem is LSA1 cannot cross area. So if these all three routers belongs to single area, then only these routers can communicate with each other. Okay. LSA1 cannot cross area. Let's say on router number 3, I am running OSPF area. This is OSPF area 1, area 1, and this is OSPF area 0 or area 2, any other area 2. So now router 1 cannot communicate with router 3. Why? Because as I told you, LSA1 cannot cross the area. So LSA1 of router 3 cannot enter in area 2, or LSA1 of area 2 cannot cross in area 1, cannot enter in area 1. Getting my point? So how router 1 and router 3 will communicate? So that's why there is one concept that whenever we are configuring two regular area, so between two regular area there should be one backbone area. If there is one backbone area, let's say this is not area 1, this is area 0, then router 2 will become what? ABR router. If it is not area 1, see, now router 2 is not ABR router, because definition of ABR router is at least one interface should be in area 0. So here R1 and R3 cannot communicate with each other. So you have to configure what? Area 0 between two regular area. So if this area is, let's say, area 0, now LSA1 of area 0 cannot come in area 2, and LSA1 of area 2 cannot enter in area 0. But we don't have problem because this router is my ABR, and ABR will generate LSA3 to share inter area prefixes. Getting my point? ABR router generate LSA3 to share inter area prefixes. Getting my point? So interviewer can ask you this question: can two regular area communicate with each other? So no guys, not communicate with each other. Why? Because LSA1 cannot cross area. So between two area 0 must be there. Okay, now I am going to show you these things practically. See, we have LSA1, we have discussed LSA1, that all routers in OSPF domain generate LSA1, but LSA1 cannot cross area. If I will talk about LSA2, so LSA2 will be generated by DR router. By which router? By DR router. So we have already discussed DR and BDR concept yesterday. Whenever one router is DR, so DR router generate LSA2 to share router information in OSPF domain. Let's say I have network like this, switch. Let me make you understand all thing, guys, why we will skip one single topic. Again, I am going to design the broadcast network, router 1, 2, 3 and 4. Let's say in this network, router 4 is DR, R1, R2, R3 and R4. Let's say R4 is DR router. So all DR other router will form full neighborship adjacency with DR only. Yes or no? Then how router 1 will came to know how many routers are there in this network. For that, DR router will generate what? LSA2. DR router will generate one LSA2. and that LSA2 will be flooded to all router. And inside the LSA2 there will be only one information, that how many routers are connected. So LSA2 is not used to share network information. LSA1 is used to share network information, not LSA2. LSA2 is used to share router information. DR router will tell to DR other that brother, there are 4 router in this segment. Okay. After that, LSA1 is clear, LSA2 is clear. LSA3, ABR router will generate LSA3 to share inter-area prefixes. Between two area, how routers are going to communicate with each other with the help of LSA3. So only ABR router can generate LSA3. Let me make you understand guys practically. Let me open GNS3 and here I am going to design one network. Ho 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 ho.
You tired?
No.
Oh,
I am very energetic person, brother.
okay.
Router 1, 2, 3, 4, 5. Let's say 5 router are there. Let me take some switches as well. Switch 1, 2, 4, and let's say 5. Okay. Let me connect this router. Okay, I did some mistake here. Let me use serial link between routers. Between routers, you already know how I will use network. Between router 1 and router 2, I will use 12 network. Between router 2 and router 3, I will use 23 network. Okay. And same topology you will also create in your GNS3. Please guys, you guys are not performing lab, so this is not fair. Okay, now here I am using network 10.1.1.0/24. Here I am using, let's say, network 21.10.1.2.0/24. This is different network. Here I am using, let's say, 21.10.1.4.0/24 network, and here I am using 10.1.5.0/24 network. Okay, after that After that, let's say this is area 0. Okay, and this is different area, let's say area 1. So which router will become ABR?
R3.
R3, very good. OSPF area 0, and here we have OSPF area, let's say 10. Okay, now I am going to turn on the device and let me configure the IP first. R1, R2, R3, R4, R5. I'm going to, write down the command in notepad and directly I will paste it here so that I can, configure quickly. So on router number 1, I'm going to say config t, and then interface f0/0 nosut and IP address 10.1.1.1 255.255.255.0. After that, exit interface serial 2/0 nosut and IP address 12.1.1.1 255.255.255.0. exit. And let me configure OSPF also. So here I am going to add one command, router OSPF 1 router ID 1.1.1.1. okay, and exit. And on the interface I am going to add one more command here, IP OSPF 1 area 0. okay, so fast ethernet 0/0 is in area 0, and this command, same command, I am going to add on serial 2/0 also. okay, now configuration of router 1 is done. Let me copy the command and let me paste it on router number 1. What happened? Router OSPF 1 router ID is 1.1.1.1, and then there is some problem. I have run exit command twice, I think. Router OSPF.
We didn't put a router ID.
ID, forgot ID.
Oh,
Yeah, I
router
wanted to say that. Yeah.
ID. Let me copy the command and let me paste it again. Now it's fine now. Yes. Okay. Now let me configure R2. So router ID of R2 will become R2.2.2, and on fast ethernet 0/0 IP address will become 10.1.2.1. IP OSPF 1 area 0. okay, serial 2/0 IP address will be 12.1.1.2 IP OSPF 1 area 0. And let me add one more interface here, interface serial 2/1 nosut IP address 23.1.1.2 and IP OSPF 1 area 0. exit. Copy the command and let me paste it on R2. okay, now R3. Router ID on R3 will be 3.3.3.3. fast ethernet 0/0 IP address. Fast ethernet 0/0 is not required on R3. okay, so let me cut this from here and I am going to paste it in the last. Okay, so on the R3 I will run router ID 3.3.3. After that serial 2/0 IP address will be 23.1.1.3 IP OSPF1 area 0. Then serial 2/0 IP address will be on serial 2/0 34.1.1.3 IP OSPF1 and area here I am going to say area 10 and then exit. Let me copy the command and let me paste it on R3. Okay, which command? Okay, this command is here. I have one problem now. Here I have not defined the subnet mask.
Also was on router 2 the problem.
Also on router 2.
Yeah, I wanted to say, but yeah.
Yes. So on serial 2/0 here I am going to correct it. Interface serial 2/1. No set and IP address 23.1.1.2 255.255.255.0. Okay. So IP OSPF interface brief, you can see OSPF is enabled on all interface of router 2. Okay, done. On router number 3 again I am going to copy this command and copy and let me paste on R3 and this time it's fine I think. On router number 3 do so IP OSPF interface brief. So OSPF is enabled on both interface. Done. Now let me configure R4. So router ID will be 4.4.4.4 and interface serial 2/0 IP address will be 34.1.1.4 IP OSPF1 area 10 interface serial 2/1 IP address will be 45.1.1.4 IP OSPF1 area 10 and fast Ethernet 0/0 IP address is 10.1.4.1 IP OSPF1 area 10. Copy it. Okay. On R5 router ID is 5.5.5. Interface serial 2/0 IP address is 45.1.1.5 IP OSPF1 area 10 interface serial. This interface is not required here. After that fast Ethernet 0/0 IP address is 5.1 and IP OSPF1 area 10. Okay, let me paste it on R5. What happened here? Here I have some problem. No, I don't have any problem here. Okay, so now on router number 1 guys, let me check the database. So IP OSPF database, and inside the database you can see there are some LSA1 router link state. This is router LSA. How many router LSA are there? 3. LSA1 of router 1, LSA1 of router 2, LSA1 of router 3, because there are only 3 router in this area. Yes or no?
Yes.
Okay, and on router number 5 also how many LSA1 will be there? So IP OSPF database 3, LSA1 of router 5, LSA1 of router 4, LSA1 of router 3, because there are 3 router in area 10. So you can see there are 3 number of LSA1. Getting my point?
Yes.
Okay guys. Okay, see inside the router LSA, if you will open LSA1 of any router in detail. Let's say this is the command to check database. I am on router number 1. If I want to check database, I will run command show IPOSPF database. Inside the database there are LSA. Router install what? LSA in database. So we are able to see 3 number of LSA1. Let's say I want to check the detailed information of router 2. That router 2 is sharing how many network. Okay, so I will run command show IPOSPF database. After that router LSA, and I want to check router LSA of 2.2.2.2. So it will show me the detailed information of 2.2.2. See, inside the LSA1 of router 2 there is 23 network, there is 12 network, and there is 10.1.2.0 network. Getting my point? So all router, if you will open LSA1 of router 1, 1.1.1.1, so it is sharing all link information. Okay, is it clear? So why, I am configuring and I have designed the topology like this, just to make you one thing, that router LSA cannot cross area. See, LSA1 of router 1 is, we are not able to see LSA1 of router 1 in this area, in area 10. Router 5, router 4 don't have LSA1 of router 1. Yes or no?
Yes.
Or router 1 don't have LSA1 of router 5, router 4. Because these routers are in different area, and LSA1 never cross area. It cannot cross area. Okay, if I will check database of router 3, inside the database of router 3, how many LSA1 will be there?
6.
6 or 5?
1, 2, 3, 6.
How 6?
So they have 1, 2, 3, 4, 5. Okay, we have 5 routers.
5. See. So IPOSPF database. How many LSA1 is there? There are 3 number of LSA1 in area 0. Yes. And there are 3 number of LSA1 in area 10.
6.
So total number of LSA1 is 6. 3 in area 0, 3 in area. Means router 1 is creating 2 number, router 3 is creating 2 number of LSA1. One for area 0 and one for area 10. Okay. So ABR router always generate, 2 number, or it depends that how many area are connected to router 3. It will generate total number of LSA depends on the connected area. Okay.
Yes.
Okay. After that, on router number 1 you can see LSA 3. On router number 3, so IP OSPF database. LSA 3 is summary LSA. Now who is generating these LSA? Advertising router ID is 3.3.3, means router 3. Who is generating this LSA? 1.1.1, 2.2.2, 3.3.3. Advertiser router ID is the router ID of router who is advertising the LSA. And only router 3 is advertising LSA 3. Yes or no? Summary LSA.
Yes.
Advertising router ID is 3.3.3.3. And through LSA 3 it is sharing, you can see 10.1.4.0, 10.1.5.0, 34 network and 45 network, all prefixes of area 10. Router 3 is generating LSA 3, and through LSA 3 it is sharing all prefixes of this area into this area. In the same way it is generating LSA 3 to share all prefixes of this area into this area. Done?
Yes.
Is it clear, guys? And now you can see from router number 1 I can ping 10.1.5.1 if source is 10.1.1.1. See, ping is working. And on router number 1 I want to check who is my ABR router, so I can run command show IP OSPF border router. So who is ABR?
Router 3.
3.3.3. And what is the cost to reach 3.3.3? 128. And if I want to reach to ABR, so I can reach through this IP address 12.1.1.2. Done. Done, guys.
Yes.
So this is one type of, these are internal router. If I will talk router 4 and router 5, router 4 and router 5 are internal router, because all interface of these two router belongs to area 10, means regular area. Router 1 and router 2 is backbone area, because all interface of these two router belongs to area 0. Router 3 is, these are backbone router, these are internal router, and this is ABR router. Done.
Yes.
And now I am going to do one thing, guys. This is in area 0, and let's say here there are one small organization who is using any other routing protocol here. Let me take one more router, R6, and on R6, between R6 and R5, the routing protocol which we are running is, let's say, EIGRP. Okay, and router 6 have one network, some network, let's say 60.1.1.0/24, 60.1.1.0/2.0/24, and 60.1.3.0/24. Let's say router 6 have some prefixes. First of all, let me configure EIGRP here. Here I am going to configure what? EIGRP. So router 5 have one interface in EIGRP domain and one interface in OSPF domain. So router 5 will become which type of router in OSPF? ESBR. Yes or no? Between router 5 and router 6, I am using 56 network. So let me configure R5. Interface F1/0, no set, IP address 56.1.1.5, 255.255.255.0, and router EIGRP as number 10, network 56.1.1.0, 0.0.255. say no auto summary. I have configured the EIGRP also on router number 5, and let me configure router 6. Interface F0/0, no set, IP address 56.1.1.6, 255.255.255.0, 255.255.255.0. I have run no set command. Yes. Interface loopback 1, IP address is 60.1.1.1.255.255. Interface loopback 2, 60.1.2.0, interface loopback 3, and 60.1.3.0. What AS number of EIGRP I have configured on router 5?
10.
So router EIGRP AS number 10, and say network 0.0.0 and no auto summary. Soon EIGRP neighborship will come up, you can see. Okay, and on router number 1, you can see so IP route. I am not receiving any 60 prefixes here, yes or no? And so IP OSPF border router, we are not able to see that router 5 is my ESBR. So until and unless you will not perform redistribution, routers will not act as ESBR. So as you know, on router number 5, I need to perform redistribution. So let me perform redistribution on router 5. Redistribution means I need to redistribute EIGRP prefixes in OSPF or OSPF prefixes in EIGRP. So router OSPF 1 redistribute EIGRP as number 10 and subnets. This is command to redistribute. And let me redistribute OSPF in EIGRP also. Router EIGRP 10, redistribute OSPF 1 matrix 1 1 1 1 1. Fine. Now on router number 1 you can see show IP route. I'm receiving 60 prefix or not?
Yes.
And this time you can see symbol is. Here I want to show you some symbol, guys. So IP route OSPF. See, router 1 has some network with O symbol only, and some network with OIA symbol, and some network with OE2 symbol. Yes or no?
Yes.
See, the prefixes which is here with O symbol are my area prefix. This is prefix of same area 10.1.1.10.1.2.0. See, this network belongs to same area. Yes or no? So this means this is a OSPF prefix, only OSPF. This means this OSPF inter area prefix. These are the prefixes of area 10. Yes or no? 10.1.4.0 and 10.1.5.0. These are inter area prefixes. So whenever router will receive inter area prefixes, it will install in their routing table with OIA symbol. And these are external prefix. Whenever router will receive external prefixes, it will install with symbol O. After that maybe E1 or E2. And now if you will run command here, so IP OSPF border router, you can see there are two border router, 3.3.3 also and 5.5.5 also. 3.3.3 is ABR and 5.5.5 is ESBR. Is it clear?
Yes.
Now we don't have any more concept in OSPF for you now in CCNA. There are lots of concept in OSPF, but for you guys, these are more than sufficient. If you will check now database, so IP OSPF database. So inside the database, you can see there are some LSA1. You already know these are the LSA1 of my area. This is LSA3, which is generated by which router? ABR router, and these are LSA5, which is generated by ESBR router. Now you need to practice by yourself. You need to read book, you need to practice, you need to watch video. There are lots of video available on YouTube as well. So you have lots of resources to learn. So from next class I will start switching.
So here I have one question.
Yes.
My question is, okay, if there's both side have a regular area, not area 0,
Okay.
then what we do?
Then communication will not happen. Let's see now. Let me do it. On router number 1, go to interface F0/0, say IP OSPF 1 and area 5. Let's say area 5, okay? Interface serial 2/0 IP OSPF 1 area 5. On router number 2 also, let me change the OSPF area. Config T, interface serial 2/0 IP OSPF 1 area 5. Interface serial 2/1 IP OSPF 1 area 5. Interface F0/0 IP OSPF 1 area 5. And on R3 also, let me change it. interface serial 2/0 IP OSPF1 area 5. That's it. On router number 1, so IP OSPF database. Now you can see we don't have any LSA3. Yes or no? Clear IP OSPF process. Yes. So IP OSPF database. Now you can see I don't have any prefix of area 10. Yes or no?
Yes.
I don't have any prefix of area 10 here because now I don't have ABR router.
So then what we have to do to connect?
So as I told you that between two regular area there should be one area 0. So in your
Oh,
network
okay.
if backbone area is not there then communication will not happen.
Okay. If both
You
is
can do one thing.
Mhm.
Yes.
Okay.
You can do one thing. This is now area 5. You have to make R3 as ABR router. So if I want to make R3 as ABR router, then R3 at least one interface of R3 should be in area 0. So let me create one loopback interface loopback 1 and say here IP address is 30.1.1.1 255.255.255.0 and IP OSPF 1 area 0. I'm going to advertise this loopback interface in area 0. Will it work? On router number 1, so IP OSPF border router. Again you can see and again you can check so IP OSPF database. We have LSA 3. Because now R3 have one interface in area 0 and some interface in regular area. So what is definition? At least one interface should be in area 0 and at least one interface should be in regular area. So more than one can be also there.
Okay. Now I understand. At least like the border router should have one interface in
Between two
area 0.
area,
Mhm.
one ABR should be there.
Okay.
Backbone area should be there.
If both area has area 0, then do we need?
Then no problem. Then we don't have problem now. Then it will work fine. Because
Okay.
both are same area then.
Okay.
If
Here
here
like
also we are running area 0 and here also area 0, that means all routers belongs to same area. Means all routers are backbone router.
okay. If both areas area 5, then we
Then
also
also we don't have problem.
got it. Okay.
Between two regular area, there should be backbone area.
Okay, got it. Same like AI GRP AS numbers. It works same like
Yes.
that.
Not same like
Not
that,
like
but yes, it is similar.
AS similar. Okay, got it.
Anything else? Any other question?
I have one short other question. Sorry for that.
Yes, yes.
What's the difference between fast Ethernet and serial? Like
Okay. Serial link is, point to point link. So on serial link, DR and BDR election will not happen. That's why I have used serial link here.
okay. And we cannot use serial link for the local area network, right?
Yes. Exactly. Okay. Anything else?
No, that's it. Thank you.
Thank you.
Okay, then can I close the lab?
Yes.
Do you need this lab?
Yes.
Yes, yes, yes.
So let me share with you. I have removed the configuration, okay?
Okay, I remove it. You can do it.
OSPF inter area. I'm going to save it in download, not in documents. If you will have same router image, then only this lab will open in your GNS. Okay,
Okay.
so I think you guys have same router. Done. So tomorrow we will start switching module, guys. Okay.
Switching model and uh, a review of a BGP.
Yes.
Yeah.
Okay. I will give you overview of BGP. Okay. Tomorrow. Tomorrow we will start BGP.
Okay. Thank you.
Okay, guys. Then bye bye. That's all for today. Which
Thank you.